Hello everyone. Today we're gonna be speedrunning again a wall in Revit using Sofistik, Civil 3D. I'm not gonna talk as much this time, so feel free to put on music in the background. I cannot put music on YouTube, so even classical music, so unfortunately it's gonna be a little silent. So let's begin. 30 seconds already. Now we're gonna do it all from scratch. Using AutoCAD drawing. Let me see where is my correct drawing. This is my correct drawing. Okay, so we have this plan view. It's messed up. It's really messy, but yeah. And we have this very beautiful profile view. Now the wall is basically split into 2 or 3 parts. There is the retaining wall part, reinforced earth part, and another reinforced earth part that is overlapping this. So you can see here, we have basically, you can see this wall. This is one wall and this is another wall. Now we're not gonna be doing this part because it's all the same and it's, I'm gonna do it later. And we have, so we're gonna be doing the retaining part, and the reinforced earth part. And which is overall, what is it? 148 meters or something. So it's a nice wall, but not that complicated, I have to say. Because as you can see, the foundation level is flat, so well, it's not really a speed run if I'm talking that much, but okay. But I'm also thinking when I'm talking, I'm thinking on how we're gonna do it, you know? Because we are gonna do it all from scratch. Yeah. There is this precast parapet, but I'm also gonna be doing it from scratch, so. Okay, I think, see this section here? This is the retaining wall. This is the reinforced earth. We're not gonna be modeling the reinforcing elements or the panels, you know, this is, we're not, how do you say it in English? This is not detailed. This is not the detailed design of the reinforced. We don't do detailed design of reinforced earth, so it goes further to the contractor, which has a specialized company that does these reinforced earth walls. You can see here it kind of gives you an indication what it's kind of like. It has these panels, these concrete panels, and you have like reinforcing strips connected to them that help to stabilize the earth. Okay. So let's begin by starting a new drawing, which has all my styles. This is an AutoCAD drawing that doesn't have my styles. Now we need to be, let's paste to original coordinates. There is also something, zoom extents. Now I'm gonna be deleting this because this is, I'm gonna be deleting this because there was a mistake in the original drawing and this is the correct one. And now I'll be copying this one. Okay, so the sections are here. And this drawing simply has my coordinate system. Where I am, the Israeli grid. Okay. So the wall, the retention part of the wall is facing that way, as I understand it, right? And this line, I mean the line in the plan view, represents this point. Okay, we have a lot to do. Let's begin. Okay, alignment from objects. Polyline. See if it's in the correct direction. I think it's not in the correct direction. Because we have it going from left to right here. So reverse it. Okay. 25. Do not add curves between tangents. I like not to erase it. Okay, delete this. Profile view, create profile view. Create profile view. Change the elevations. Now I'm gonna be aligning to the 35 level. Now here we need to be careful. Where we move this, we need to move it. Where is our line? Our line is here, going here, 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 here. And so this should be this point, if I'm not mistaken. Let's hide this. Yeah, we see that it's aligned. Let's see the length. Yeah, as we can see, the length is almost spot on. Maybe there's a couple of millimeters here. 5 millimeters, ignorable. Okay. So we basically need a line for our main axis, which we always make horizontal. So we're just gonna use this polyline. I have my command PFP. My Lisp, let me load it so you can see the name of the, I found it online, profile toolbox. You can search it. PFP, select polyline, select profile view. Why didn't it create? Why did it not create? Are there profiles already? Let's see. I don't think there are any profiles. Let me try again. Is that the polyline? Yes, PFP. Okay, now I did it. Change the name. You have to change the name here. Okay, now this is the top of the parapet, which is this point here. Or this point. I'm not really sure. There is a little bit of a difference. Let's see. There is a 1 centimeter difference. So I don't know right now. I'll take What will I do? I'll take the I think I'll take the outside measurement. I think that is more correct. So this is the top of our parapet. What is this line? We don't have an arrow pointing to it. Okay, but we don't need any more. Just the top of the parapet. Let's see that it's continuous. It's not continuous. Let's continue it to save our time. Okay. And again, this command is really a time saver. I want to see that I'm recording. Let me see. 11 minutes. Okay. Okay, so we have the top. Now we don't need a profile for the bottom. We're just gonna do it with the parameter. And because it's just 2 levels, right? We don't need we have an expansion joint here, so it's just gonna be 2 parts, the retaining wall and the reinforced earth wall. Okay. So do we have everything we need here? Let me think. Wait, am I wrong here? Why is the hatch stopping here? Let's see. Is it because... Why is the hatch stopping here? Maybe it's just a mistake. Wait a second. I think we don't have this over... How could that be? Wait a second. There might be something wrong. This is 146. I think there is still something wrong with this. How are we gonna do it? Like, I think there is something wrong. Unless I moved something? But I didn't move anything. This tells me 148. But this is... The length of this is 146.85. So they corrected it, and again, there's something wrong with it. What is this one? 2518. This is 2518. Let me see. This is 3 meters. 3 meters length. 146 plus 3 is 149.85. This says 148. Why is it saying 148? Ah, because it's with this overlap. Here it shows an overlapping. Let me see if I imported the wrong drawing. Here you can see it. Why? So here you can see the overlap. For some reason, did I import the wrong drawing? This is 148. This goes here. How did that happen? Let me think. Yeah, these sorts of things happen. I don't know what I did wrong. I'm just gonna... It doesn't really matter. I'm gonna bring this again. This is real time. It's not like I made 10 videos and I put them all together. You know, this is like, this is what's happening. I could start over, right? But, you know. It's something with the import. I see. For some reason. I think I understand. Some reason the block is kind of moving. Let's explode the block. Even though it's painful. Now see that it's alright. Yeah. So again, the 35 level. And it looks alright. And now where is our profile? Where is our profile? Did it disappear? Okay, I don't know what happened to the profile. Just a second, let's see if we have a profile. We have a profile here. Why am I not seeing it? Stupid. How is that possible? Where are my profiles? I can't see my profile. No, it doesn't matter. Takes 2 seconds. Join. It's gonna be faster than this from now on, yeah. Pretty sure. That's the 35. Okay. Now PFP. I really don't know what happened when I moved the drawing. I don't know. RW 25. Stop. So the profile exists somewhere, but I can't see it. Okay. Okay. Okay, so now what do we need for this drawing? We need displacement. And we need this expansion joint. Other than that, yeah. Okay. Feature line, form alignment, enter. Enter. Site none. Otherwise, it's not gonna work. Main tool. Name. Okay. 55. Top 2. Okay. Now this is another wall that we did. It's very similar, but we're gonna start from scratch. We just have the view arrangement and the coordinate system. Let's save this drawing. Let's go over this one because we did it before they fixed it. So now let's do this. And I want to just import it to make sure everything is working. Link card. I like to work as much in 3D as I can. Let's see, where is the drawing? Why I can't see the drawing? Ah, here it is. I like to work as much in 3D because you can see everything. And with the yellow, with the white, you can't see it. What am I gonna do? Let's quickly change this. Let's put it on gray. Or what is it in AutoCAD? Let's see. What color is this? Is that black? Looks black, but something like this. Okay, now we can see it. But you're not used to seeing Revit like that, are you? Well, for me, I wouldn't mind, but let's, yeah. Don't know what is better. Stick with the white. So stick with the white. Okay. Now go back to civil. Export. Go to the prospector, feature lines, export to land XML. Okay. Now W25 access. Back to revit. Sofistik Bridge, access, import. 25 access. This one. Now see that the lengths are good. Yeah, the lengths are. You see the station at the end. That means if we know what the length of our alignment is, we know that it's brought it correctly. Sometimes, like in the other video, it didn't do it correctly. By shared side, horizontal, okay. See that it comes here, where it should be. Indeed. Now we're gonna remove the extra placements. Let me see that the settings are correct here. Okay. Don't update elements after changes in access, because that's gonna be annoying. Import. Top short site. Okay. Here you see that this is below the main, but that's correct. So the main is at 35 and it's, and see the coordinates, elevation, spot elevation. So you can see it's doing it by the project base point. We need by the survey point. 35, okay. Okay, remove the placements. Okay. Now the fun begins. Now what we need is to first we'll create the reinforced earth section. So we'll start by this wall, and we'll have the blinding concrete here, the wall, and the parapet in the same family, the cast in place parapet. And we'll have a length parameter that will control the visibility. Okay. Now what I'm gonna do is I'll do this. Let me think. Where is this? This one. Okay. Now new family. We don't need the project browser. Okay. Oh, we don't have this showing. It's gonna be annoying. You know what? Let me see. Okay. So basically, for a superstructure in Sofistik, we need an adaptive family, generic model adaptive, with exactly one adaptive point, one placement point, and as many shape handle points as we want. You will see what I mean. We'll have one shape handle point for the top of the wall. Okay, start by placing a point here. This offset doesn't really matter. Offset horizontal. Okay. And this is gonna be a rotation if we want to flip it. Okay. Now we're gonna create a reference line. I can't work with millimeters, centimeters. Make it 3000. Now make this adaptive. Change it from point placement point to shape handle point. Give it a name top. Doesn't matter where it is horizontally, just matters where it is vertically. Okay, and now post point by intersection with this. Okay, and this is the point we're gonna be working with. Now the leg of the wall is gonna go this way. So we can see it here. First of all, we need an offset. So we need a point to be offset from this. Okay, and this is the point we're gonna be working with. So we're gonna first create this part. We're not gonna do it parametrically because it's a fixed. These are fixed. These are fixed quantities. You could just add the parameters. So this is 48 centimeters. Forty-eight centimeters. And now this is 25 centimeters. See how much this goes in. 22, is that 22? Yeah, 22 centimeters. Minus 22. If you have all these families ready, of course, it's much easier. Much faster. We would maybe approach the finish line already. Maybe. Okay, let's see. This height. 1 minus 1, 1, 5. Okay. See this length here. 1.5 meters minus. How much is this? 25. And to finish, we'll go down from this point, this distance, which is 1.1. And we have the first part of our wall basically finished. Minus 1, 110. So now always spline through points, pick 2 points. The other commands here don't work as well from experience, so don't try them, just spline through points. Yeah, this is annoying. Spline through points. Okay. See, we have our. Let's measure it. Should we measure it? Let's set the plane here. What is that? 22, 25. What is this difference? See, we didn't make any mistake. $150. Yeah, that was 150. I want to see the vertical distance here. Let's see that if this distance is 124, yeah. Yeah, I think it's good. Okay. So we're gonna put it on a visibility parameter. Wall. Now we're gonna do the blinding concrete, which for us is always 5 centimeters. Outside and down. You know, it makes sense not to try and optimize these sorts of things, like make your drawings always like when someone sees your drawing, he knows like, okay, the blinding concrete is always gonna be 5 centimeters. So I don't need to bother. Is it 10 centimeters to the side or 7 centimeters? Sometimes I see like irregular measurements, like 10 centimeters out, like, you know, it's blinding concrete, it's not structural. They want to put 10, let them put 10, you know. You don't need to sanction it. Okay. Just makes everything more readable or comprehensible. Okay. Almost done with the blinding concrete. Oh my god. Needs to go out 5 centimeters. No, I made a mistake with this point, doesn't matter. Again, you could make this parametric, but why bother? Okay. Almost done. The advantage you're doing it in the same family is, of course, you know, you make the change once and everything is, that actually sits against the wall here, so that shouldn't be 5 centimeters. Here they also didn't do 5 centimeters. So actually that was correct what I did in the beginning. But here we leave it. Okay. I think this is a mistake, I'm not sure. Okay, visible, blinding. Okay, blinding. Now what do we need? We need the parapet. Okay. So we are, I said at this point we need to go down by a centimeter. And what is the distance here? 2 centimeters. Okay. 2 centimeters down, right? Ah, we are here. Okay, so go up by 23 centimeters. Let's isolate this. Twenty-three. Two centimeters. Okay. And the width is 50, right? 50. Just to make sure. Isolate. $50. How much is that? 24? No, 25, right? 26? 26, yeah. so this is 26. Okay. Now we have it all selected. Give it a visibility. And parapet. Snow, okay. Now return here. We're gonna have a visibility parameter for visibility. Okay, so 0. If the parameter is 0, it's gonna be blinding concrete. For visibility equals 0. Parapet is gonna be greater than 0. Wall is gonna be less than 0. Okay. We don't have many parameters here, just this. Okay. Now let's load it into our project. What project is this project for? Let's save this project. This is our older model. Why is this stuck here? Okay. Now we have all we need basically to do the wall. Now we have to make sure we understand the leg of the wall goes this direction, right? And we need a placement for where the wall ends. Let's go back. Now we start from this. We're gonna measure the X direction, of course, the X. Now what I want to get exactly the middle between these 2 points. Line. So I'll know to just go out 2 centimeters. What's the length of this? 2 centimeters, okay. So now distance. So the X 125.938. Let's try and remember it. 125.938. Let's go back and make sure that that's the correct one. Let's see. 25.938, okay. Why is it not sticking? Okay. We're not gonna do this rail, this is too much. Maybe we won't model it, maybe later. Okay, so Superstructure create. We are not modeling expansion joints for the reinforced earth. Family 116, we didn't give it a name. Did we model it incorrectly? We didn't model it correctly. It should always be on the left, right, and we model it on the back, you see here. But that's a quick fix with our rotation. So like I would start over again, but for these purposes, now we see that what happened to our horizontal offset? Okay, let's see if something we... Some reason it's not sticking. Let's see. The browser, how do we do the browser? Oh, I forgot all of... I never would take it down. How do we do the browser? Property. It's embarrassing. I'm used to embarrassment. Where is that? View. Visibility. Let me quickly check online. Revit browser. Okay. View. So convoluted user interface. Browser. Okay. So now families. The horizontal is probably not an instance parameter, which it isn't. And the rotation is always gonna be plus 90 degrees. Rotation. So what we do is Angle. Okay. Always put this offset parameter because, you know, you never know when you might need them. So everything we did basically got spared, you know. We didn't work in vain because of that parameter. Sometimes you can add it after the fact, sometimes you can't. So, okay. Okay, now we can walk. That took a little bit of time. Now this is the top point. Now we gave it a name. Now it appears here in the parameters area. And we simply access reference, variation type, access reference. And then we can select the access from a list, or we can select it manually with this little thing. Okay. I'll double. Let's start with the wall itself. So now the vertical offset is gonna be 1.26 minus 0.26 minus 0.26, and we'll do the wall. Okay. Now do we have everything? Placement, shear mapping. And now this is very nice here. We can give it an offset from the placement. So minus 0.01. Horizontal projection. And what else? What else? I think we can ignore polycurve connection points. And just run it. Hope it's gonna be on the right side. Maybe it won't. I think it won't. But we'll see. So if it won't be on the right side, we just give it a 180 degrees, yeah. So this is the wrong side. So just 180 degrees. I think it's on the wrong side, right? Yeah, it's... Now that I'm thinking... No, it's on the right side. Oh, it's on the right side. Because the leg has to face this way. Otherwise it doesn't make sense with the overlapping of the wall, so... Let's see that horizontally it's alright. I mean that... What is this? Oh. So this should be on the axis. Where's the axis? Yeah, I think it's okay. Now, as we can see, it goes with the top line. And this should be 26 centimeters. 31, 31.1, 30.8, 6, 20. The height is, the elevation is weird to me. Let me get the calculator. 31.14. 31.14 minus 30.888. 25. Little strange. What did we give it? 26? 26 centimeters. Okay, let's do the parapet and see. The parapet should fall exactly on that line. So superstructure duplicate. And now for visibility is 1. We just need to change this. This is another good reason to use multiple sections in one family. Okay, so this is gonna be the parapet. There could be some inaccuracy, like 8 millimeters or something like that, but I'm not sure. And it's hard to see these axes in sections, so. But let's see. Only it's. Oh, this is the correct way, right? Let's consult our drawing. Yeah, this part is sticking from this side. Okay. Okay, now the blending concrete. I think it's okay. A bit of a difference, maybe. Look, we're not building rocket ships here. We're only building bridges, you know. Let's see. Okay. You basically spend no time modeling. If you have the families already, you spend 0 time modeling. Like, you're just transferring information from Civil to Revit and solving problems along the way. As you can see, blind in concrete. Okay. Now we go back and we do this wall, this representing the panels. There's a little mistake here, but doesn't matter. And the foundation and the reinforced earth, the earth element, which we're also gonna model. I think this is 0.8 of the height. Let me check for a second. I think it's 0.8 of the height. Okay. And this wall is pretty easy. Now I'm gonna be starting with this family that we already have. And basically, it's gonna have the same parameters. We could have put all the sections in this family, but turn it all to reference lines. But it's maybe a little bit too much. So now we already have something to work with. We don't start from scratch. So let's isolate this. We're gonna make the part representing the panel elements. Let's return here. So this distance is also not parametric. So from here to here, this is 1 centimeter and about 1 centimeter. So this is 1 centimeter. And 1 centimeter down. -1. And this is gonna be the panel width. Panel width. It's in all caps, but doesn't matter. The panel width is, let's remind ourselves, 18 centimeters. Okay. Panel width is 18 centimeters. Okay, now we need the bottom, which is a little more difficult. So basically, I'm going to, wait a second. I'm going to give it a parameter that we take from this level of the insertion point, which we know is always at a fixed elevation, which is in our case 35. And we're gonna go down by that parameter. So we'll call it bottom offset. And then this is exactly this line. And we know how much to go outside to get to this level. Or we can do a reference line from this and do host point by intersection, but do it more simply. Okay. So now we need an offset from this. And this is gonna be x1. And offset for wall bottom. It's gonna be negative. And now the offset let's say 200. Now we have this point. I'm gonna go outside. And how much is this? 25 plus 1? I think it's 25, right? 20, 26. Let's return, make sure that we have it right. Yeah, this is 26. Okay. $27. And this is going to be the level of this level of the foundation. So we need to go up by the foundation thickness. Okay. I think it's under an hour for the retaining. Oh my god. For the reinforced earth part. It's pretty good, I think. Panel width. Don't try to go too fast. Should remind myself that doesn't work. Okay. And now this is gonna have a visibility. We're gonna change the name. The wall we're gonna leave the same. Now the foundation. Very simple to do the foundation. Let's give it X2. This capitalization is just so annoying. X3. Okay, foundation width. Let's see the default value. 50 centimeters. 50 centimeters. And these are going to be foundation width minus final width divided by 2. And this is gonna be minus x2. Okay. X4. And x4 is the foundation thickness negative. Foundation thickness. What is the foundation thickness, by the way? 20, okay. Now, again, the visibility is gonna be perfect. We're gonna change the name. Perfect. Perfect. Again, the capital letters. Okay, and the blinding is gonna be Earth. Earth segment. Okay. Now we're gonna do the Earth segment. Again, let's advise our plan here. It shows it from this level, but I don't think it matters. We're gonna do it from here. We wanna go 1/8 the 0.8 of the height, I think, if I remember correctly. So now, the problem is sometimes this is above our. Sometimes this is above our. Sometimes the insertion point is above the top of the wall, so it's gonna mess up if we do we should have moved that axis somewhere. You know what, we'll just move it. We'll move the axis, it won't affect the other family at all. We'll just move the axis. Wait a second. We'll move the axis down by somewhat. Let's say to the 25 level. Okay, and this goes, we need to measure to our shape handle point here. This is the shape handle point, right? Okay. So this, we're gonna give it a label. Now instance reporting parameter and height 1. And now we have Earth width Now it's gonna be this. Okay, where are we? Where is the width? Earth width? I'm just thinking offset for the bottom of the wall and height 1. Height 1. Now to use this inside the family, it has to be between adaptive points. So that's why I can't measure from, let's say, from here to the top, and it won't work. So this times 0.8. I know it's not correct, it's just an estimation. Can be used in a formula only if it's to host elements. I think I know what the issue is. Let's do this. I just copied it. I think there's another point here that it's pointing to. Yeah, let's add this point. Didn't I set it? Okay. Now this is height 1. And now we paste it. Now it's gonna work. What is this? What did I do? Foundation width. Yeah, there was a parameter that was deleted. Earth. Okay, now we'll take this point. No, we just need this point. What happened to the foundation thickness? 50 centimeters. So we need this point, this point, this point. This point. What point did I take, let's say? Took the wrong point, I think. Let's create our earth already. We'll figure out the parameters after that. Okay. Now the parameters. X5 is earth width negative. And X6 is I think what it is. X6 is earth width plus x2 plus the panel width plus the panel width, and let's return here. Excuse me now. It's from this one. So this is what we said, centimeter or 2 centimeters? Centimeter, okay. So it's that plus this and minus 1 centimeter. Minus 1. No, we did something wrong. Let's see. This is not x5. I didn't set it. Let's see if everything looks okay. It looks alright, I think. It's only 3 lines. Let's isolate this. See that it's okay. Okay. So this is the earth segment. And with that, I think we're finished here. Let's save it. Capitalization is just so time consuming. Now we're almost done with the reinforced earth part. Bottom part. Foundation width. This, what needs to change here? This is 0 minus 0.26. I didn't move the axis. Wait a second. I want this to be beneath the top of the wall always, so let's move it by 5 meters. So now the offset to the bottom is from 30 down to the level of 28.5. So it's 1.5 meters offset. Let's check that this is on the 30. So we said 1.5, right? Duplicate. Okay. Minus 0.26, 0.5. The top is this one. Rotation, was the rotation 0, I think, yeah. Rotation thickness, panel width. I think that was without the angle, so I'm not gonna bother. This is a speed one. Okay, 90. It has to show here on the left to be accurate. Okay, so this is the Earth. Earth. Okay, that's okay. I will already think of the retaining wall part, which is so simple. It's really gonna take us not a lot of time. Just a wall and a base. Usually it can be sloped or something. This is really simple. We're not gonna bother with a lot of variables here. Oh, there is a parapet, yeah. And there's the precast parapet to do. Why did this do it? Obviously something went wrong. Let's try. What went wrong here? I think something came out of attachment, like one of the points is not attached correctly. I think the top point maybe. Maybe I moved the axis, maybe? Oh, the axis seems alright. Wow. Okay, let's edit the family. And this is moving together. Didn't move down. This is moving together. I don't understand why it's... That's very weird. Trying to think why is... Here we see something. Also not right. Why is it doing that? Trying to think of the reason. Let's edit this family. So here we can see our insertion report is here, and this is going outside by so much. Why is it going outside? Again, I don't know. Let's see. Why is this going in by so much? What's the problem with these families? Something I did really wrong, and I just don't know what. Like in the family, it's going together. Why is it not attaching? Ah, because went outside of. Oh, this is 30 meters. 6,000. I hate it when in the family it's working perfectly and outside it's like something went wrong. You don't know what. Yeah. Let's change the rotation. Maybe this is the problem. Oh, it's still attached very well. I really don't know what happened. Really don't. Like this is going inside for some reason by so much. Why? Like here is the adaptive point. Why is it going in so much? Why? Let's see the parameters here. X5. Let's try and investigate. Offset horizontal. Is there a horizontal offset here? I just offset. There is an offset. The horizontal offset is still not a. Yeah. I see. Let's see if it resolves it. I'm gonna have to run it again, so. And now do it with 90 degrees. See what happens. The point is, when these things happen, don't overthink it. Like keep just trying things till you figure it out. Because sometimes it's just gonna take so much energy. Okay, now it looks good. Okay. Now we just duplicate. And for visibility, -1. It's the wall. Now there's someone at the door, so I am going to leave you for a little while. Yeah. We just return the sorry. I'm not an expert. Wait a second. Okay, let me return. Is that flipped or something? No, man. Okay, let's see what it did. Now we will need to look in a section because you can see it like this here. First of all, what happened to the earth here? So it is, okay, it is continuous. Okay, now, yeah, I think it's alright. And now we'll duplicate it here. And visibility is 1. Need to drink a little bit. Okay. Let me think what we need here. This is not perfect, but I see. It doesn't matter for these purposes. Earth, okay. So now we finished the reinforced earth part. Let's just check the elevation. 28.5, it's okay. And now for this small part here. Okay. Let me just think for a second what we need. We need this simple wall here. It's pretty repetitive, like it's the same thing. You know what, let me do the precast parapet. I'll do the precast parapet. Explode. I'm gonna bring it over to Revit. Okay, I'm gonna save it. Perfect. And we're gonna do the precast perfect and see if I have the energy for this little part here. It's really small and not that interesting. Okay. New family. Generic model adaptive. Units, centimeters. Now we're gonna put our profile here. We're gonna give this an offset. And the rotation. Now we're gonna insert import card. No, this is not 80. It is 80 centimeters. Let me try and delete this abomination. Now, is it correct? Something looks off here. This is 80 centimeters. 10 centimeters. Okay. Here, 55 centimeters. 55 centimeters and 143. 143. And the radius. One, two, three, four. And there'll be 5. 5. Okay. Can I rotate it like this? No. I think it's stuck like this one. Okay. I haven't done this in a while, so it shows. Move it here. Now we're gonna create a cross member using an adaptive, generic model adaptive with two adaptive points. And it's basically gonna create like an extrusion or a loft between these 2 points. So what we need, first of all, let's load this in. We need it to be vertical, right? But we need all the offsets, horizontal and vertical offset. You can make a lot of stuff like this, rails and railing and parts of bridges, and it's really convenient. Change this to centimeters, because and these, we want to give these a rotation also. Let's see how this is gonna. So this is 90 degrees to what we want. So what we need is to do this, I think. Okay. And now the same for the other one. Okay. And now see when we change the rotation, 180. No, it's not flipping. I know what we need to do. Wait a second. Ah, it is flipping. The round part is facing this way. And now the round part is facing that way. Okay. So basically we're almost done. Make this invisible. Create a form. Give it the material. Now load it. And now we're gonna use this axis and we're gonna take it outside by 50 centimeters and create our parapets along that axis. Cross member create. Create between placements, fix spacing every 2 meters, let's say. We didn't give it a name. No. What family is this? Cross member 128. Offset horizontal is 50 centimeters. Vertical is 0. Let's say this is 0. You can see here the preview is really nice. So it's gonna start here. It's gonna start here in the beginning. So it needs 180. And now it's minus 0.5. Okay, I think we're done. Is it correct? No. Why is there an overlap here? Because it's curved. And it's in the wrong direction. Ah, the beginning, the end is there. Okay. Let me first do this. Oh, zero. Now the issue with the curved part, I don't think we're gonna mess with that. Like, it will need some major adjustments. So again, why is this incorrect? Like maybe it will work. Let's see. Yeah. And this is too ugly. Delete this. What we need is an access. Access from curve. Unfortunately, it's not very. I hope this is gonna join into one axis. Otherwise, here you see there's a little line. I don't think it's gonna join. We create the axis, and to make it work, we need a lot of work. You see. This is not gonna work. What should we do? Let's see if it's gonna join it. Yeah, so for part of it, it did work. We could also do is go here, secondary access, add. We create in a secondary access. Let's see where it creates it. Okay. Now let's try the same thing with this axis. Now we need 0 vertical, 0 horizontal. 180. Let's see if it works. It should give a better result. Not perfect. 180. Yeah, here where the radius is big, obviously it's not gonna, like, you need a special part here to make it work, like. Or maybe if, like, this geometry is not, like a straight geometry is not gonna work here, right? So we're gonna leave it like that. Here it's also not that good. We could fix it, but we're not gonna bother. Like, we could give it an angle and inside the family and work from there, but It's really above and beyond the Call of Duty. So give it a material. Precast. And that part is finished. Should I do the retaining wall part? Let's do it, let's do it, let's do it. So the retaining wall part. We have a parapet. We have a wall. But it's so simple that it really shouldn't take too long. New family. Make sure we're working on the right plane this time. We don't need that offset. We don't need that offset now. It's the same thing as before, like, it's no difference. So the leg is gonna be to this side, the long leg. And this point signifies this, okay? First of all, give it an offset. Now, usually there's a different thickness to the bottom and the top, but we're just gonna give it one thickness. Let's see what it is. This is 48, 45. And the bottom, let's see the measurements. 20, 30. 45. Now offset for bottom for wall. Not short leg thickness, width. We also have thickness, man. Of course, I have these sections in other projects, but we're trying to do it from scratch here. Okay. If, long leg width. Let's see how much it is. 155. see that we measured it correctly. Okay. Okay. So now this vertical, yeah. It's the offset here. Okay. Okay, now 4 lines here should be. This is the wall instance. And now the blind in concrete. I already explained everything that we basically did the same exact thing there, so with the retaining, with the reinforced earth. So there's really nothing to add. Just again and again and again the same thing. Yeah, let's see this. Blinding. Now we only need the parapet for this. I'm gonna do the parapet in a different family again. Okay. For is it? Okay. Hopefully we did everything okay. Let's give it a name, save it. Retaining Now we have a placement, an extra placement. Or do we? Wait a second. Yeah, we have a placement. Let's measure this precisely. Our placement is at 136.835. One. 136.86. Is that correct? Let's see. 136.835. Again, check it. 835. 835. Okay. So now we're going to use a repeater, which we haven't done so far. I did it on the previous speed run. Now repeater here. Retaining wall. Visibility 1. Now offset. Offset for bottom, top of wall offset. Minus 0.26. Offset for bottom of the wall. Our axis is at 35 and this is, it's at 30 and this is 29, so it's 1 meter. Offset is 1 meter. 155. All of this we entered already. The top is this axis. Now at the start we wanna go inside a centimeter. At the end we want 0 and gap between 2 centimeters. Horizontal projection. Now only these 3. WL. Shear mapping. Let's see what it does. Think of how fast this can be if you have the families already. Like instantaneous. Enter a few parameters. If you have 2 screens, you know, one screen you can check the what parameters you need, the other screen you enter them. And it's like 28.7. Why is it 28.7? It's very weird. Annotate. 30. 29. Ah, I see. This is 29. So this is 30. So this is 28.7. No, this is 29.3. So we need 0.7. Yeah. It's a mistake. Now I see that the precast parapet is not vertical. We need to change that. You know what? Let me see if it is vertical here. Let me check it in the section view. Okay, this is upside down. Yeah, this is so ugly. And this looks vertical. Obviously, it's got other issues. This is vertical. Okay, this needs to be flipped. And as you can see, it created two sections with a little gap in between for the expansion joint. Now superstructure duplicate. What happened there? What happened there? Is there a horizontal offset? I think maybe again the horizontal offset is incorrect. Again, I didn't make it horizontal. This doesn't have a parameter. Like you probably saw that when I was doing it, like when you're just watching, you see things that I can't see, right? Because I'm trying to talk and everything. Not that I'm that good at talking, but You don't go into engineering if you're good at talking, right? Doesn't make sense. You become a lawyer, some professor of arts, of something. No, it's okay. Now for the parfait, I think we're just gonna utilize the same family. It's basically this. It's gonna give exactly the same result. We're just gonna duplicate it. Okay. And now the blind in concrete. I didn't sleep that well today, so it wasn't as fast as the previous speed run, but I tried my best. I'm not gonna do the earthwork part because that is really a job for Civil 3D. Let's see what it does. Okay. And now before I forget, I have to change the name because we have like a software that does material takeoff from the based on families, based on the family name. It knows what article to put for the because every concrete has a different price. So we can't just do all concrete as one price. So we have to separate it. And now duplicate this. Okay, this doesn't have a lot. Top part, reinforced earth. Superstructure. Repeater. Where's my access? Superstructure. Repeater. We do everything right. Let's see. And with that, we're almost done. Almost. Just a little bit more. And I will present it much nicer than this. I'll hide all the excess and the AutoCAD drawing. Hide everything, hide everything. Hide this. Now let's put it on realistic. Already looks nicer. We'll do this. That doesn't need to cast shadows. Let's do lighting. It's a little bit hard to see. Let me do another change here. Now it's more visible. I did sky. Why is this not showing the sky? Sky. Okay. Maybe show the edges. Nice wall. A little bit scratchy. But this part looks nice. Well, I hope you found this helpful. Hope you'll use it on your projects. Some of the information maybe. Maybe you just enjoy just seeing how things are done. Maybe it's not the correct way, but maybe there's a better way. This is how I'm doing it, so thank you. Let's see how much time we were. Wow, 2 hours 45. Okay, this is a long one. Okay, bye bye.